So next is collision probability. Okay, so it is defined in this way. So collision probability is the number of collisions suffered by a molecule on average in moving a unit distance. Okay, so if you consider a molecule, okay, and if you observe that it is moving a unit distance, and in moving that unit distance the number of collisions suffered by that molecule on average is called collision probability. That is, in moving a unit distance, in different point of time it may suffer different number of collisions. Okay, so if you take average of that, then the average number of collisions in moving a unit distance will be called collision probability. Okay, and it's denoted by P suffix C. That is, P is probability and C is for collision. Okay, so how it is related to mean free path. So we know that the mean free path is defined in this way, that it is the average distance travelled by a molecule between two successive collisions. That is, suppose there is one molecule, okay, this one, and suppose at this point it collides with another molecule, okay, and we are observing this red one. Okay, so at this point this red molecule collides with the black molecule, and after that it is moving in this direction. Okay, so after reaching this point over here it will collide with another molecule. Okay, so according to the definition of mean free path, we can say that on average, after suffering this first collision, on average it will travel a distance of lambda before suffering the second collision. That is, between two successive collisions, this molecule, this red one, will travel a distance. On average it will travel a distance of lambda. So this is the average value. That is, between two collisions, this red one may travel a distance less than lambda or greater than lambda or even equal to lambda. That is, the lambda is the average value. So between two successive collisions, this molecule, this red one, may travel a value less than lambda, may travel a distance less than the mean free path, or greater than the mean free path, or even equal to mean free path. Okay, but on average it will travel a distance of lambda. Okay, so we can say that after a molecule suffers one collision, it starts moving, and on average it will travel a distance of lambda before suffering another collision. Okay, so we can say that on average the molecule will travel a distance lambda, and the number of collision it will suffer is 1, that is this one, because it has already suffered this collision. Then it is traveling a distance of lambda and it will suffer another collision. So on average it will travel a distance of lambda to suffer this one collision. Okay, so we can say that on average, okay, the distance traveled by a molecule is lambda, and then it will suffer one collision. Okay, so it has already suffered one collision, then it starts moving. on average it will travel a distance of lambda before suffering another collision. So this one. Okay, so we can say that on average after traveling a distance of lambda it will suffer one collision. So on average after traveling a distance of lambda, that is the equal to mean free path, it will suffer one collision. It may travel less than this path or greater than this path, but on average it will be equal to mean free path, that is lambda. So on average if it travels a unit distance, how many collisions it will suffer? It will suffer 1 by lambda number of collision. Okay, so on average in traveling a distance of lambda, a molecule will suffer one collision, where lambda is the mean free path. So in traveling a unit distance, how many collisions it will suffer on average? It will be 1 by lambda collisions. And we know this is the definition of collision probability, that is the number of collisions suffered by a molecule on average in traveling a unit distance is called the collision probability. So this 1 by lambda is the number of collisions traveled by suffered by a molecule on average in traveling this one means unit distance. So this 1 by lambda is the number of collisions suffered by a molecule on average in traveling unit distance, and we know that number of collisions is called collision probability. So now we have found that the collision probability PC is equals to 1 by lambda. That is, there is a reciprocal relation between the mean free path, where lambda is the mean free path, and the collision probability. So there is a reciprocal relation between the mean free path and the collision probability. So it means that if one molecule has a large mean free path, means after suffering one collision it will travel a greater distance between before suffering another collision. That is, for a large value of lambda, what does it mean? It means that suppose a molecule suffer one collision over here, then it will travel this large lambda before suffering another collision. It means that the probability of the collision is less. That is, it has to travel a great distance before suffering another collision. So the probability of collision is less. So probability of collision will be low. But if lambda is small, what does it mean? That is, after suffering a very short distance, it will suffer another collision. That is the probability. So the probability of collision in this case will have a high value. Okay.